G'day, my name's Steve and this is Reevesy's Workshop, and this is part 3 of building the Garratt, and we shall continue on with the front water tank. So we'll start by marking out holes, drilling holes and continuing on from there. I'm happy where the holes should go. You can see I've marked them out with these crosses. Now I need to be able to drill them out accurately, so I've got my spring punch and I'll just very carefully go in to where I want the hole to be. That gives me a little dimple. I'll now take this off, followed up with a bigger center punch so the drill can be guided correctly, and then I can start the drilling operation. I bought myself a good quality hole saw for drilling the larger holes for these bushes, and they work very well. The holes are now all drilled and the plate sits on the tanks okay, but something I did notice that I didn't think about before was as the locomotive's going across the track, it may actually bounce, the tank may actually bounce up and down on this plate. So what I'm thinking of doing is I'll make some brass bushes up for each of the pins between the R-clip and the floor to stop that happening. And I may have to put some additional bracing in this floor as well, but we'll find that out once we get the locomotive going. To make the bush, I've got some free machining mild steel and off cut from something I'd done previously. You can see it's all rusty, so first thing I'll do is clean it up with a bit of wet and dry or emery paper. Then I'll take it out and do the other side. Next I'll lightly face off the end so it's all square, taking a 5 thou cut. A little bit of lubrication as always. Nice fine feed rate. Now we'll bring in the centre drill and centre drill it. Just being careful not to put too much pressure on the centre drill in case you snap it. We'll follow this up by pilot drilling it. You do this so that you don't put too much load onto the bearings of the little lathe. then I follow this up with the finished size hole. In this case here, the pins are 9.5 millimeters in diameter, which is 3/8 of an inch imperial. So I've grabbed a 25/64 drill, which is a shade under 10 millimeters diameter, and drilled a hole with a little bit of clearance. You never go too far in case you jam the drill bit out, so pull it out, re-lubricate it, back in again. Nice even feed. Doing about 5 to 8 millimeters cuts at a time. Last operation is to deburr everything. Now I'm going to turn the bar around, drill it from the other side until I've got a hole all the way through. That'll keep the hole concentric, and then I'll go over to the bandsaw and cut it off into 17 millimeter lengths. Before I cut it in the bandsaw, I'm just going to use my calipers here to mark out the length, which is 17 millimeters. Nice deep scratch there so I can see it, and I'll pull this out, turn it round and do it the other end, and then go over to the bandsaw. So I've now set it up in the bandsaw, as you can see, and we'll cut the first 17 millimeter length piece. Just watching it very carefully, as the blade will tend to speed up a little bit when it breaks through the piece, or the section I should say, where the hole is. Other than that, it's cutting pretty smoothly. Here's our finished result. Looks pretty good. Now I'll flip it all over and mount it back on the chassis. The person doing the CAD drawings for me is now in the process of doing the CAD drawings for the rear tank, And he suggested while we do that, we should have a look at the footboards for the driver to ensure that the driver sits comfortably on the loco. So he sent me this CAD drawing showing me what he'd done on his own locomotive, and from there I've drawn up a sketch of how to adapt it for my own engine, which he'll now draw up for me to send to the laser cutters with the other parts. And I've decided to include a few photographs as well to give him an idea what he's looking at, to make doing the drawings much easier. I've got all the paintwork bolted on now and it's looking pretty good. The only thing that I had to adjust was this corner was slightly out and I needed to hit it on the side here just to bring that in a little bit, but you can see it's all pretty uniform now. And it's looking pretty good. All I've got to do now is the little side pieces here, which look a little bit plain, so I think I'll fit some dummy screws to them to make it match the rest of the tank. My friend that's doing all the CAD drawings so we can send them off to the laser cutters to get things cut has just sent me the latest lot of drawings. So based around these sketches here, he's come up with all these drawings you see here for making all the various parts for the rear tank. Quite a lot of work involved, as the rear tank is a little bit more complex than the front one was, but it's a project I look forward to getting stuck into, which we will do in due course. As cutting the angles is a very time-consuming process, tapping the holes, drilling the holes and so forth, and we've got 27 angled items to cut and make. Now I'm going to leave the front water tank for a little bit and get stuck into these angles while we wait for the laser to cut the parts for the rear tank and then for the sheet metal worker to bend them. Just like before, it's a matter of getting the pieces of angle down from the roof, very carefully measuring their length. You can see my little setup here for holding everything. And then it's just a matter of cutting things. Got the spring tension on my bandsaw set up just right for stainless steel. We don't want the blade to rub, we need it to cut, otherwise it'll go blunt very quickly. As you can see, I'll just go down a little bit closer, that it's cutting through the angle quite well. As a result, the blade should last. 27 pieces to cut. It's going to keep me going for hours. One thing that you need to be able to do is to be able to sit comfortably while driving your engine. So I purchased this seat. I think they use these on forklift trucks and gopher mobiles and things like that. Has an adjustment down here for sliding it back and forth, and you can see the sliding pieces there which will bolt onto the rear tank of the Garratt. I've used these seats before and they're pretty comfortable, so that'll work in with the footrests. I've decided for this round of end milling that I'm going to keep the cutter at the 26 RPM so I don't have to change the belts. And as you can see, that's reduced the tool loading on the end mill considerably. I'm actually doing a 1mm cut here, and you can also see that the finish is coming up quite nicely. So I'm going to cut the rest of these angles using this speed and feed rate. Did a bit of clunking, but I've used plenty of cutting fluids and it's working out quite nicely. Back on machining the angles for the rear tank, and you may be wondering how I set the vise up for the 45-degree angles to do the corners, and this is how it's done. I'm using a dial indicator that measures in 0.01 of a millimeter increment, and then I've set up my angle gauges. I've got a 30-degree and a 15-degree together, lightly pinched in the vice jaws. That gives me 45 degrees. Then I just swing the vise around approximately the 45 degrees and then measure along the edge of one of those gauges. And the idea is to gently tap the vise around either way, whatever's needed, until you can see that the needle on the dial gauge isn't going to move over a certain distance. This is a fairly short distance, but it's more than accurate enough for what we need to do. You can actually see that the gauge has moved slightly. It's moved 0.02 of a mil. Well, that's about a thousandth of an inch, and it's so small that I'm not going to worry about it being slightly out. You're probably just measuring the errors in the table, possibly the head moving, things like that. It's such a small unit of measurement, it's not worth worrying about. But it gets my vise at 45 degrees, and now I can mill the end of the angles as you saw when I did the front tank. You may be wondering how I managed to get the vise back parallel with the milling table. Well, this is how I go about it. I've got a parallel bar loosely sitting in the vise. It's just nipped up enough not to damage it, but to hold it firm against the edge. Now normally this finger here for the dial indicator would actually rub against the back jaw, because the back jaw is your reference point for all your work. However, I don't want to move my head around and spoil a setting that I've got for the next set of work, so that's why I've put this parallel bar in instead, and that enables me to have the head up a little bit higher and the dial indicator a little bit higher. So I'm using that back edge to get the vise in the correct place. So like we did with the 45 degrees, I can tap either end of the vise depending on what reading I'm getting. So what was happening before I showed this footage was the needle was moving between the 0 and the 5, and then I was knocking it with the hammer half that distance, going back to the start point, resetting to 0, then moving the table across right to left. Whatever reading I picked up then, I halved that by tapping the jaw of the vise, went back to the start point, and I just kept doing that until I finally got it so the needle hardly moved. And you can see now that the needle's staying pretty well close on 0. It's actually 0.001 of a mil out. You can just see the needle has moved a fraction. But like I said before, it's so close to being where you want it to be, I'm not really going to get it much better than that. So I'm going to leave it as is. And now we're ready to start the next stage of work. Here are some parts that have just come back from the laser cutters, so I thought I'd show you these, give you an idea of what things look like when they come back. Being stainless steel, of course, they have a protective cover on one side, and this is the side that's on the outside that you see. Although in my case it's a little bit not worth it because I'm going to end up painting it all. But if it was a stainless steel project, then you want to see nice shiny stainless steel at the end of building something. Here we have some items for brackets, and there are two parts for these brackets. They're actually a hinge, so they get cut. These little segments here are showing the little joining pieces between components, to there, to there, to there, to there. So I will cut those out, and then I will clean all this up, and we're using the tongue and groove method. So these here go into slots to be welded. I'll show you more of that process as we go along, but this gives you an idea of what to expect when you get things laser cut. So that brings us to the end of building the Garratt part 3. We'll continue on with more of the build in part 4. So see you then.